which is a near equatorial site, and we're prepared to do that in the mid-January timeframe. I'll turn it over to Dante for to answer the second question.
Yeah, the rocks on the asteroid surface have turned out to be fascinating scientifically, and the team has done an amazing job processing all of the remote sensing data that we've acquired starting in late 2018 and throughout 2019. I can answer the question that, first of all, the surface seems to be dominated by two distinct rock types. We see a very dark, kind of hummocky rock, which looks like the one that we crushed underneath it. And from recent analysis using the thermal data, how the rock heats up and cools off, we actually inferred that these rocks might be very weak compared to what we're used to dealing with here on Earth. And most exciting, I think, for me as a sample scientist, very weak compared to the meteorites that are currently in our collections here on Earth. So I think what we've seen is that our meteorites are possibly a biased sample, that they're only the most sturdy and strong material that survives passage through the Earth's atmosphere. And it looks like the material that dominates the surface of BENNU might be much more fragile and friable. And with this interaction of TAGSAM with the asteroid surface, that seems to be playing out. I can tell you the science team is already excited about the possibility of getting a direct strength measurement through detailed analysis of this image sequence, especially these two images right before and right after contact. The second kind of rock that we've seen on BENNU is a little brighter. It tends to be shot through with bright white veins or white inclusions that we've identified as a mineral carbonate. This is a mineral people are probably familiar with. It forms a kind of white crud around your faucets and sinks if you live in an area with hard water. It's basically an evaporite, and those rocks seem to be a little stronger, probably because of that material that has cemented them together. We do see maybe some hints that there was some of that brighter material, smaller fragments of it, underneath the TAGSAM head, but the team is going in for detailed analysis to determine if that's in fact the case. And then I'll just add, mineralogically, we've done a pretty good job understanding what these rocks are made out of. They're definitely dominated by hydrated minerals, that is, clays that have water contained in their crystal structure. That's very exciting scientifically. We've also seen an iron oxide called magnetite, abundant organic material, particularly carbon-hydrogen bonded material, which is really what this mission is all about, bringing back home, and then that carbonate material that I mentioned earlier.
Thank you.